Okay, here's the video going along with the spot check 20 that second period took. It was today. For the first function, you have to fully factor it and decompose it as much as you can before you can sketch. So I first look for a GCF. It's 3, comes out of the numbers, and then an x. And x to the first power is common between all three terms, so you factor out the x. When you divide 3x into each of these terms, you're left with this trinomial. That, we always try to factor it with the magic x because that's the easiest way to try to solve. So what works here? Well, I think it's minus 3 and plus 2. That adds up to negative 1, but multiplies to negative 6. So that's undoing double distribution. So this x, this minus 3 goes into a binomial, the plus 2 goes into a binomial, and now we have fully factored our expression. What are the zeros from these factors? The 0 from a monomial is just 0. Right there is 3, and right there is negative 2. Let's analyze the end behavior of this function. Right side is positive, left side is different because the exponent is odd. And so we know our graph needs to look like this. Plot these zeros like I've done here, and then draw your sketch through the intercepts. Over here on G and H, you have to find out if it has real or imaginary roots. See if you can factor each expression. Factor out the negative 1 from G. This does, in fact, let's see, negative 1 and negative 30. Yeah, I can make that work with a negative 6 plus 5. That's why these two binomials are created. Once you get that, hey, I know I have two reals because these are both going to be, the zeros are 6 and negative 5. Down here for H, I don't think I can factor that, so the only thing you're left to do is use the quadratic formula. We're not doing the quadratic formula, you're just evaluating the discriminant. In this case, it's b squared minus 4ac, which will be 36 plus 12, which is a positive number. So again, I know I have two real solutions. That's it.